DT classes. Today we are going to discuss the real analysis. So before we start the real analysis, I think all the students which are in the +3 first year or second year, or which are going to prepare for the JAM or any m.sc exam. First, remember that in DT classes we will provide you all the syllabus that covering the b.sc and m.sc entrance package. So first of all, I introduce myself M. So I am pursuing PhD in mathematics, and today we are going to discuss a topic, real analysis. So what is real analysis? We already know the real number system. That is, real number system is consisting of natural number system. From the natural number system, if you extend the natural number system, it will become the set of integer that you have already know it in your previous classes, and if you expand the set of integer, it becomes rational numbers. And the set of rational number including set of irrational number, that is called the complement of Q. That means any number which cannot be both rational or irrational. That means any number, any real number may be rational or may be irrational. It cannot be both. It is either rational or irrational. So set of all rational and set of all irrational, they have combined to make the real number, that is the set of all real number in the world. That is the set of all real number in the form of Q or in the form of Q prime. So that is the first basic definition of real number. Before we proceed, we first introduce the progress one by one. Suppose we introduce the real number system in graphical manner. Okay. First, suppose we know what is natural number. The natural number consists of 1, 2, 3, 4, like that, right? Infinite numbers are there. Starting from 1. Suppose we want to show these numbers graphically. So how we show there? Suppose if you have any graph paper or maybe in hands. Suppose starting here, we got 1 and 2, 3, 4, 5 like that. Suppose in a straight line. Okay, suppose it's a straight line. So starting from 1, this is 1, this is 2, this is 3, this is 4, this is 5 like that. So this is the geometrical representation of natural number. Now, if you move to the set of integer z, now we already know that what is z? Z is 0, plus minus 1, plus minus 2, plus minus 3, like that. Now this z can be represented geometrically in this straight line. Just extend this line. This is positive side. Now this extend this side in negative directions, and this is your 0, which is in the middle of positive and negative, and this is clearly minus 1, minus 2, minus 3, so and so on. So this is geometrical representation of set of integer z. Now after the z we got q, which is the superset of z. So q, what is the form of q in mathematically or in algebraically? Q is any number which is of the form p by q, where pq belongs to z and q not equal to 0. That means any number which is of the form p by q, where pq belongs to integer and q not is equal to 0, are called as rational number. So how we represent rational number graphically or geometrically? So let's see how we present. Suppose we have a number. So, and rational numbers are two types. Generally, one is proper and improper, that you already know. If it is a proper, then it must belongs to 0 to 1. Within 0 to 1. How? Suppose 1 by 2. So 1 by 2 definitely it must be greater than 0. If it is positive, greater than 0 and less than 1. If it is negative, it belongs to suppose minus 1 by 2. It is less than minus 1. Sorry. If it is minus 1 by 2, it is like that. So that means any number which is of the form p by q, where p is less than q. If it is positive, then it belongs to 0 to 1. If it is negative, then it belongs to minus 1 to 0. So first, how we present any proper rational number. That means a number which is of the form p by q. If it is positive, it belongs to 0 to 1. If it is negative number, then it belongs to minus 1 to 0. So first draw this one. So this is first so this is 0 and this is 1. So let's expand this one. Okay, in another format. Just zoom it, just like you zoom in your mobile. So just zoom this picture 0 to 1. Now this is 1 by 2. So what is the meaning of 1 by 2? That means twice of 1. So making this part as that means divide this part as 2 parts. This is 0, 1. This is suppose any part. So among the 2 parts, what is the numerator? It is 1. That means you have to take 1 out of 2. So this is the 1 by 2. This noted. This indicates the 1 by 2. This is noted the rational number 1 by 2. Suppose we have another rational number. Suppose 3 by 5. 3 by 5. This is also a proper rational number. So how you present graphically? You present graphically like this way. You present graphically in this way. That means 0, 1. This is 5. That means you have to divide 5. 1, 2, 3, 4, and this is 5. And you have to take 3. This is 3 by 5. That you have already know. That means any proper. Suppose this is improper fraction. If it is improper, like 7 by 2, you have to make it into the form of mixed fraction. That means 7 divided by 2. How we divide? 2, 3, 1. So it will be written in this way: 3 whole 1 by 2. So that means it is equal to 3 plus 1.5. That means how you represent 7 by 2 in this number system. 3 plus 1 by 2 means that means you have to first go up to 3. That means 0, 1, 2, 3, up to 3 you have to go. Then after 3, you have to go half. That means 3 to 4. In this part, you have to divide 2 parts and have to take 1 part. This one. This represents 3 and half. So I have done this for proper fraction and improper fraction for positive rational number, and this is the similar way you can do for the negative rational number that you have already known in your previous classes. Now, my aim is that what we have got, that in this system we have represent graphically the natural number, the set of integer, and rational number. Now, my aim is how we can represent irrational number. Suppose we have any irrational number like root 2. Is root 2 can be represented as any point in this line? Yes. How it is represented in this line? Let us see. Now this is 0 and this is 1. You may already know that in your previous classes. Suppose this is 0 and 1, and make a 90 degree over here at one point, at point 1. So what is this length? This length is 1. Now measure this length and put this length over here and join this. So what is the length of this? That means it is a right angle triangle which both sides are 1. So it is 1 plus 1 square plus 1 square root over, which equals to 1 plus 1 root over, which equals to root 2. That means this length is root 2. So measure this length and put an arc or put a signal here, put an indication here. So we get this measure length will be found to be here. That means this is your root 2. That means what I am going to express, I am going to express that the irrational number also can be found to be a point in this line. That means all the numbers, like all the natural number, integer, rational number and irrational number, all are being points in this system. And one thing is that this all rational, irrational that being packed in this line. That means all the real number is nothing but a point in the line. Point in this line. That's why this real number is called as a real line. In geometrically it is called as real line.